Alrighty, we're moving on into the next section. Hopefully you're feeling a lot more confident and comfortable with using substitution as a method for solving systems because graphing just isn't always the most accurate. It doesn't necessarily give us whole number answers, and you can't estimate well, and we just need a better method. So now that you've learned substitution, I also want to show you another alternative when maybe graphing and maybe substitution itself is not a good approach. Okay? All right, so I need you to write these two down in our system of equations. 3x plus 4y equals 18. 2x minus 4y equals negative 8. Now, if I were going to solve these, I'd isolate my y variable, get it in slope-intercept form, and I'd end up with something like y equals negative 3/4 x plus 18/4. And already I'm like, bleh, because I've got all those fractions. If I'm graphing, this is not going to be the most accurate. Similarly on this one, same thing. And if I were going to attempt substitution, maybe I'd target this second equation and try to get x by itself because it looks like at least everything's even and so on and so forth. But I want to show you another method when substitution just seems to be kind of clumsy or a lot of work. Okay? And so what I need you to do is just go back and think with me for a moment. Do you remember that it's perfectly legal to add the same thing to each side of an equation and the equation stays balanced? Okay. Likewise, it is perfectly legal to multiply both sides of an equation by the same thing to keep that equation in balance. You just kind of rewrite it in another format and the equality stays true. So let's take a look at these things again, okay? And specifically, let's just look at that first equation. I have this blob equals 18. Well, here's what I'm going to do. I'm going to add the same thing to each side of that first equation. But what I'm going to add on the left side is 2x minus 4y. And on the right side, I'm going to add negative 8. Because if I'm telling you they're equal, I can add this on this side and this on this side, and it should stay balanced. Okay, everything will stay equal. Now watch what happens. When I add and combine like terms, okay, the 3x combines with a positive 2x here, and I get a 5x. I have a 4y and a negative 4y term on this left side of the equal sign. Those two go to 0y, so I'm not even going to write those. On the right-hand side, I have a positive 18 and a negative 8, which gives me 10. So you really, after I add these two equations together, I get 5x equals 10. Get out of town. Are you kidding me? That means x has to equal 2. What? Let's go on our journey and figure out what y has to be equal to. I'm going to use the first equation, and I'm going to substitute now a 2 in for x. When I substitute that in, 3 times x is now 3 times 2, that's 6. I now have an equation that's only in one variable, so now I can solve it. Woohoo! For y. 4y equals now 12. Oh my goodness, y equals 3. Now, hold your horses. You had better check these because I'm saying the solution is 2, 3. Well, let's double check these. If I plug a 2 in for x, I'm going to do that in a different color up here. Here's my check. I'm going to say 3 times 2 plus 4 times 3. That's x. This is y. 3x, 4y. I better get 18. 12, or not 12, 6 and 12. I'm jumping the gun there a little. Worked in that one. Check the second equation. X is 2, y is 3. this is x, this is y. I get 4 minus 12. I get negative 8. Negative 8. Whoa! Hey, that was pretty slick, this elimination thing. Now, let's take a look at why this worked or what our strategy is going to be. Okay? Basically, to eliminate, if you want to use this strategy, what I say is line up the equations vertically directly underneath each other. It just makes it easier to see. So put your x term first, then your y term, then the equal sign, and then your constant. Basically, it's get each equation in standard form. I think makes it the easiest. Okay? Then, if necessary, multiply one or both of the equations by something so that you get a coefficient either in the x terms or the y terms that are exact opposites. Because then when you add these two equations together, those coefficients wipe out. You've eliminated one of the variables and you can solve for the other one. And then you are cooking with gas. So let's get going. Okay, let's take a look at this example for a system of equations. I have 2x plus 6y is negative 14. I have negative 2x plus 4y is negative 16. Okay, first thing, make sure everything's in standard form and lined up, meaning x term, y term, equals signs, constant. We're good. All right, now let's take a look at these coefficients. Do you have opposites? If we don't, we need to create some. When I look here, 2 and negative 2 are exact opposites. They're going to 0. Shazam, here we go. I don't have to do any multiplying. I can go right to add those equations together to eliminate a variable. So here's what we're going to do. Okay, here's your equal sign. Everything's lined up here. Add the x terms together. That's 0x. That disappears. I get 10y. On the right-hand side, I get negative 30. Oh my stars. You get y equals negative 3. All right, now we have to figure out what x is. So let's go back. You decide which one of these you want to substitute a value of negative 3 in for y. I'm just going to use the first one. 2x plus 6y, oh, put negative 3 in, has to equal negative 14. That gives you negative 18. And then I get 2x minus 18 is negative 14. Add 18 to each side. Now you should be able to figure out what 8 is. Just have a seat, Heaven. I'll be right there. And now you can divide by 2 and divide by 2. And you should get x is positive 2. Go back and check these and let's see if you have got the right solution. So we're saying it should be 2 comma negative 3. So let's substitute 2 in the first equation. 2 times 2 and then 6 times negative 3. You get 4 and negative 18. I get negative 14. Yes, that worked. Check the second equation. Okay, you really have to check both of these. Negative 2x. Let me move this up a little bit. So I said x was 2, and then 4 times the y value, which I said is negative 3. Let's see what happens. Negative 4, negative 12. I get negative 16. It works. All right, try this next one, and let's see if we can get this one set up. Is it?